Hello everyone. So we are going to discuss in this lecture. So this is our lecture number 2. So in this lecture we are covering the main things related to vectors in equilibrium, how to draw these vectors, scale diagram, and vector addition. In the first part of the video, we are going to cover the first concepts. In the first part of the video, we are going to cover these two things, and in part 2 we are going to cover vector addition and close triangle. So here is our part 1. The topic: vectors in equilibrium. Vectors in equilibrium, or sum of the vectors we have, is 0. So the previous case we have seen that if we have two vectors, how can we add them? Now we are looking at if we have vectors, how can we find the resultant? And if the resultant is 0, what would be the orientation of vectors? So for that we are going to take an example of a photo. Let's say we have a photo on a wall, right? It is hung with two strings.
Okay.
So these red arrows and the weight is in downward direction. So this is your weight. And what do we have in these red arrows? How can we represent them? These are actually the tensions, T1 and T2. So how do we get this tension T1 and T2? Because it is hung with the wall using a string, and in strings, which force do we have is tension force. We have studied in O levels different types of forces, and tension is one of them. So what is a tension? Let's say if you are holding a
Yes.
bucket in your hand, so it is attached with this string. So the weight is downward. So the force that by which it is in its position, let's say it is the bucket, is the upward force. So it is always away from the object on which we are applying the force. And from your source, it is in the downward direction. So if we are talking about the photo, this photo that is hung on the wall, so the tension is away from it. So is it clear? The tensions and weight. So we have three forces.
Again, I
You didn't get. You didn't get the part for
yes.
the tension. What is tension? Okay, let's say there is a person and there is another person, and they are both holding a string. This is a string. So
Okay.
person A, person B. So person A is pushing the string towards itself, and person B is also pushing it towards itself. So if I just detach the person, let's say if this is a person A, so in person A, the force, the tension is in this direction, right? It is
Yes.
holding towards the object, and for the person B, it is going away from the object. It will be like this. So just like
Okay.
the object we have on the wall. So if we have a string, so the string is used to hang the object on the wall. This is your actually points on which you have tied these strings. So the string is holding the object. So the force is towards the point where we are just tying it. So this is the direction of your strings. So is it clear? The direction of
Okay.
strings. So right now we have seen that how we can have an object on the wall, and when we have an object on the wall, which forces are on the object. So now we are going to do free body diagram. So what is a free body
Weight
diagram?
diagram?
Body diagram. So there is an art to draw this free body diagram. So how do we draw this free body diagram? So let's say we have an object. This is an object. And in drawing free body diagram, the first principle under consideration is that the object is rigid. Object is.
Okay.
So what do you mean by that? Object is rigid. So let's say you have an object and you have its center of mass. Let's say this is called center of gravity or center of mass. So in your physics course, center of mass and gravity are same, but they can be different when they are in the different gravities. So it's not in your course. So let's say this is your center of gravity or center of mass. All the weight acts on this point P. So if we apply a force on this object in any direction, let's say this is your F1 or this is your F2, this is your F3, this is your F4, we are applying forces in many directions. So if it is a rigid object, we can consider that all forces are acting on its center. If object is rigid, forces act on the center of gravity, right?
Yes.
So instead of making the shape of the object, we can simply draw that this is a point. So the whole object can be represented in the form of a point like this. So now we are going to draw the forces acting on it. So let's say this is F2 with the same orientation. This is F1 with the same orientation. This is F4 with the same orientation. And
Okay.
this is F3 with the same orientation. So this diagram is called free body diagram.
Okay.
So let's say we have the object again, the photo we have with the wall. This is tension 1, this is tension 2, and we have like the angle with it, theta 1 and theta 2, right? And the weight is in downward direction. So these are the two
Okay.
forces. Now we are going to draw the free body diagram for it. So let's say this is the point. This is the center of mass of the object. This one is your T1. This one is your T2, and this one is your weight downward. So we have represented the whole forces, but this is not actual representation. We also need to include the angles. So this is theta 1 and this is theta 2. Okay, so the
Okay.
next thing, if it is in equilibrium, how can we know that this is in equilibrium? The object is in equilibrium.
Hmm. Equilibrium.
Hmm. There is only one possibility, that the sum of forces, external forces
Okay.
acting on the object, is zero. So how many forces do we have? Is T1, T2 and W.
Okay.
So T1 plus T2 plus W is equal to 0. So if the answer is 0 in this case, this is the only condition that ensure that the object is in static equilibrium, not dynamic. It may be the it may be in dynamic equilibrium because of the moments acting on it, but it is in stationary equilibrium, static equilibrium, you can say. Sum of forces is zero. But how can we know that the forces are zero?
Okay.
So we are saying that the object is in equilibrium, and we are also saying that the sum of forces is zero. So if the sum of forces is zero, so how can we get to know that the sum of forces are actually zero?